Formula 1, F1, engines energy recovery, how they work, and when teams can change their engines, do you know? The latest generation of power units in F1 is the most complex to date. It combines a combustion engine with an energy recovery system, also known as the Electric Power Unit, EPU, or Energy Recovery System, ERS. From 2014, this has been the formula, but plans for the next generation of power units are already taking shape. Starting in 2022, the development of engines will be frozen. This will allow manufacturers to focus more on the development of new power units that are geared towards sustainable fuels, which are expected to be introduced in 2025. But how much power does an F1 engine or power unit produce? Combustion and electric motors together produce over 1,000 horsepower. This is significantly higher than a regular road car. F1 engines can reach up to 15,000 revolutions per minute, RPM, but due to restrictions, they usually stay around 12,000 RPM. With this power, an F1 car can reach 0 to 100 km per hour in 2.6 seconds, and the maximum speed reached recently was an impressive 370 km per hour. The highest speed recorded with an F1 car so far was 400 km per hour. The Mercedes team reached this speed with a car modified at the Bonneville Salt Flats in the present day. What kind of combustion engine is in the power unit? The engine is a 4-stroke 1.6-liter turbo V6. The engines are designed based on strict size and material restrictions. With cylinders arranged in a 90-degree configuration and 2 intake and exhaust valves per cylinder, the turbocharged engine uses a compressor to pressurize it. It operates through a turbine connected to the exhaust system, driven by the airflow from the car's exhaust. The fuel mass flow, or the amount of gasoline sent to the combustion chambers, is limited to 100 kilograms per hour. This restricts what it can bring in and limits the amount of power produced. What type of fuel does the engine run on? The fuel used is based on standard, non-special additive gasoline and should contain 10% advanced sustainable ethanol. In a race, F1 cars can use a maximum of 110 L of fuel, which means they use 1/3 less fuel compared to the thirstier V8 engines. So, what does the energy recovery system do? The ERS recovers energy from both the exhaust and brakes, converting it to electricity, which is then stored in a battery and used for extra performance. This is a bit of a complex topic, so bear with me. The motor generator unit, kinetic MGUK, is an electric motor connected to the engine crankshaft. It acts as a generator to slow the car down using engine braking and charge the battery by turning kinetic energy into electric energy by spinning the tires. Later, as a motor, it uses this electric energy to turn the wheels for extra acceleration, but it can only be used for about 33 seconds per lap. Next comes the motor generator unit, heat MGUH, which is even more complex and is used in conjunction with the turbo. It acts as a generator that slows down the turbo rotation by providing a resistance. This helps prevent the turbo from producing too much boost at high power levels. It also converts this kinetic energy into electric energy stored in the battery. As a motor, this system is used to keep the turbo spinning when the driver is off the throttle, reduce turbo lag, and smooth out power delivery. Most importantly, any electric energy generated by the MGUH can be used to directly power the MGUK, providing extra power, limited to 33 seconds per lap. So, the more energy teams can extract from the MGUH, the more power they can generate. How much power do electric motors produce? The MGUK generates 120 kilowatts, which is approximately 160 horsepower. However, its use is limited during starts to prevent hyper-accelerations until the car reaches 100 km per hour or 62 miles per hour. The power is controlled by the drivers and the onboard computers. Teams develop motor maps to use electrical power in different ways. The drivers select among these maps and let the car handle the rest. Is the ERS system dangerous? Actually, yes, it can be dangerous. The ERS is a high-voltage system that can reach up to 1000 volts. Therefore, it can cause a severe electric shock. To mitigate this risk, high-voltage cables are orange. And the voltage is cut off in case of disconnection. The energy storage, MGUH, and MGUK all have high voltage connection boxes, that's why they have danger warning signs on them. They are closed in different ways and equipped with two status lights marked with a high voltage danger symbol to show the operating and insulation status. So, how are F1 cars started? Teams use an external starter motor placed on the car to start the combustion engine in the garage, on the pit lane, and on the grid. Engines are also equipped with anti-stall systems to prevent them from stopping when the driver loses control. How many power units can teams use in a season? Years ago, there were no restrictions on engine usage. So teams could spend millions to produce engines that provided maximum power but could only last a few laps. Nowadays, to keep costs down, teams are given a maximum of 3 engines, 3 turbochargers, 3 MGUHs, 3 MGUKs, 2 energy stores, 2 control electronics, and 8 exhaust systems per season for each block. If a team exceeds these limits, which they often do, they receive grid penalties. How does the FIA ensure that the engines are legal? The FIA carefully monitors teams by installing sensors and specific standard parts throughout the power unit. In the ERS, there are several electric DC sensors, and a special top sensor is placed on the MGUK. In the combustion engine, the fuel pump is standard, and 2 fuel flow meters are installed to monitor flow rates. You can thank Ferrari, who was allegedly caught opening up the fuel flow in their 2019 car, for this. Each output shaft and each drive shaft are also equipped with a torque measurement system, and pressure and temperature sensors are placed on the fuel injectors to keep everything legal. That's all we can say with the F1 engine guide. These engines can appear extremely complex because they are indeed. Today's engines are the most efficient engines Formula One has seen so far, and it will be exciting to see how Formula One engines will evolve in the future with the 2025 regulations just a few years away.